Hey everyone, my name is Milena and I'm a third-year student at the University of Toronto studying physiology and immunology. Today I'm going to be showing you how to do a very simple experiment called sink or float. In this activity, you will test whether various household objects sink or float when placed in water, and we will learn why this happens. This will also help you practice hypothesizing, which is predicting what will happen in an experiment. These are the materials you'll need to do this experiment. Feel free to use whichever household items you have available and that you would like to test. Mine here are just examples. First, collect the items that you will use for testing in this experiment. Then, fill the bucket with lukewarm water. Before you add an object, predict whether it will sink or float. You can create a sheet to keep track of your predictions and then add the results when you're done. Place the object in the water and observe what happens. Make sure to write down your results. Try this experiment again with a regular orange and then with a peeled orange. What happens? So what makes objects sink or float? You might have noticed that some of the heavier objects ended up floating and some of the lighter objects ended up sinking. This is because an object's weight and size isn't the only thing we need to think about when we're trying to figure out if an object will sink or float in water. We have to consider an object's density and buoyancy. Density is how close together the tiny molecules are that make up every object. If the object's molecules are really close together, then they'll have high density. If they're far apart, then they'll have a lower density. The density of water is 1 gram per milliliter. So if an object has a higher density than the fluid it's placed in, it will sink. If it has a lower density than the fluid it's placed in, it will float. Buoyancy is kind of like the opposite of gravity, which pulls things down. Think about what happens when you put an ice cube in a glass of water. The ice cube displaces or moves some of the water to make way for itself. And then the water level rises a little bit and the ice floats partially in the water and partially out. How far in or out of the water your ice cube will stay depends on its density, because this is what the pushing and pulling forces are working against. So what about the orange and the peeled orange? How do you explain that? Well, the orange with the peel will float because the peel has little pores filled with tiny air pockets throughout its surface. This increases the buoyancy and helps the orange become a little less dense, and comparatively less dense than water. So the orange will float in the water. The air pockets are kind of like little flotation devices for the orange, and of course, when the orange doesn't have the peel anymore, it's missing those flotation devices, so it ends up sinking. You might be wondering, how can a huge ship float in the ocean? Well, the average density of the total volume of the ship and everything inside of it, including air, which has a lower density than water, has to be less dense than the same volume of water that it's displacing. So as a ship sets in water, it pushes down and displaces a certain amount of water that's equal to its own weight, and because its density overall is less than that of water, it is able to float. On the other hand, when a ship sinks, it's because water enters the ship, which forces out air and makes the average density of the ship greater than that of water, and it ends up sinking. Thank you everyone so much for watching. Make sure to follow us on Facebook, Instagram, TikTok, and subscribe to our YouTube channel. Bye!